Hello all, my name is Olivia and I will be presenting my project titled Concentrated Animal Feeding Operations: How America's Large-Scale Production of Animal Products Contributes to Anthropogenic Climate Change and What You Can Do. Animal feeding operations, or AFOs, congregate livestock, feed, waste dead animals, and process them on a plot of land to which they are confined for 45 days or longer in a calendar year. CAFOs must contain 1,000 or more animal units, with an animal unit being more than 1,000 pounds live weight. The breakdown is 1,000 beef cattle, 700 dairy cattle, 1,500 swine, 125,000 broiler chickens, and 82,000 laying hens. Currently, there are 450,000 CAFOs in the U.S. that are also characterized by their discharge of waste into waterways or lagoons. The prominent greenhouse gas associated with CAFOs is methane, or CH4, which is emitted through enteric fermentation in ruminants. As you can see here on the left, the rumen is the largest compartment and is also the center for digestion. Methanogens, or methane-producing bacteria, break coarse food down in the rumen and produce methane, which is released through flatulence, belching, and waste. Here's a diagram highlighting enteric methane emissions across the world. As you can see, ruminants contribute to 30% of global methane emissions, with cattle contributing the most. Here to the left is the comparative warming effect of carbon dioxide as compared to methane. As you can see, methane is higher, and that is because it is 84 times more potent in the atmosphere than carbon dioxide. Here is a pie chart breaking down greenhouse gas emissions in the U.S. as well as what contributes to methane emissions. Here you can see methane contributes 10%, and as you can see here, agriculture contributes 9%. The waste accumulated by CAFOs is relatively high, with 1 day on a CAFO equating to 16,000 daily humans waste. CAFOs in 2012 produced 369 million tons of waste. Manure is not treated, which will be discussed later on in policies, and often contains methane, a gas, nutrients such as nitrogen and phosphorus, metals including zinc, copper, and lead, as well as antibiotic-resistant bacteria and growth hormones. Waste management is one of the major problems associated with CAFOs. As you can see the image on the left, which is a pile of manure that will be used as fertilizer. Fertilizer containing manure can be used on other agricultural practices, such as those that grow crops that are used for feed for livestock. Manure is often stored in anaerobic containers, retention lagoons, or is released as a point source pollution into waterways, or a non-point source pollution as fertilizer on crops. Poor waste management can lead to groundwater contamination, including fecal coliform bacteria. That can also be done through flooded retention ponds and poorly constructed lagoons, as well as point source pollution creating dead zones in aquatic ecosystems, as seen here in the Gulf of Mexico dead zone, which spans 6,474 miles and is a result of heavy rains in the Mississippi watershed, as seen here, that are flushed down full of high concentrations of nutrients and fertilizer and waste into the Gulf of Mexico. Nitrogen and phosphorus, two common nutrients found in manure, are in excess, can create algal blooms in cyanobacteria and surface waters that create hypoxia zones that have limited to no oxygen, creating fish kills and biodiversity loss. As you can see here, the green, red, yellow, and orange shades show areas with limited to no oxygen, with red having 0 oxygen. Next, we will be discussing energy and water use in CAFOs, which is highly intensive. The beef fossil fuel energy input per unit of food produced ratio is at 35:1, with swine and cattle CAFOs using the most amount of water at 2.3 billion gallons of fresh water. According to the USGS, 16,000 gallons of water are needed to produce 1 pound of beef, with Americans consuming on average 27.3 billion pounds of beef annually. Here we have a bar graph showing the years from 2002 to 2019 and consumption in billions of pounds of beef alone in the U.S., not including poultry or swine. CAFOs and greenhouse gases. CAFOs contribute to 9% of global CO2 emissions, 37% of global methane emissions, and 65% of global nitrous oxide emissions, with methane having 20 times the warming potential of carbon dioxide and nitrous oxide having 300 times the warming potential of carbon dioxide, with 2020 estimates being of 9.39 million metric tons of CO2 equivalent of methane. Here are the social and economic impacts associated with climate change. First is that the temperature increases will particularly impact areas that are more vulnerable, typically areas in the Midwest and the South, due to geographic locations, and they're areas that tend to be flat and have more sunlight. And in doing so, this can cause increased drought and create problems such as the Dust Bowl that the U.S. has experienced in the past, as well as increased heat waves. These heat waves can shorten frost seasons for crops, as well as induce crop kills, and these crops are used to feed these livestock, as well as inducing heat strokes in livestock. Increasing temperatures can also increase precipitation levels in some area while decreasing in others, again inducing droughts, as well as promoting extreme meteorological phenomena such as hurricanes and tropical storms that can pull heavy nutrients and algal blooms further out into the ocean, further impacting, as well as the loss of capacity to work. And these areas, again, will particularly impact areas that contain more CAFOs, as seen in this slide. As you can see, areas with a deeper maroon are those that have a higher livestock density and in turn typically contain more CAFOs. And as you can see, it is in the Midwest. There's some scattered throughout the South as well as on the West Coast. And as you can see, a lot of these, minus what's happening in the Midwest, are along the coast, as seen in North Carolina, Texas, and California. And these areas, such as the Midwest and the South, are areas that will face more of a temperature increase in response to climate change, thus heavily impacting these operations. Following is a case study of the Smithfield plant in Tar Heel, North Carolina. Nicknamed Porkopolis, the facility pictured here is a 1 million square foot facility and is the largest pork slaughterhouse in the world, processing on average 32,000 swine daily. A case study finds that the Smithfield plant in Tar Heel, North Carolina releases 3.6 million pounds of pollutants into waterways and across Smithfield, and completely they produce 27.3 million pounds of pollution in 4 years. They pollute 60% of waterways surrounding the facility, including the lower Neuse River, which empties into the Catesby River and then further enters into the Atlantic Ocean. Due to community resistance and losing their 5th consecutive lawsuit, Smithfield has created a commitment to sustainability, including a 25% reduction in greenhouse gas emissions through working with Dominion Energy, 75% reduction in solid waste, 10% reduction in water usage, 5% reduction in global energy use, 0 violations in wastewater into natural gas setups. The current policy lacks to cover technological advances as well as increase in demand. Clean Water Act first identified CAFOs under Section 502 as a point source pollution, as well as the use of the National Pollutant Discharge Elimination System permit, but currently only 30% of CAFOs have this permit because it is not required by any states, as well as the lack of amendments, as I mentioned before, about technological advancements and demand, as well as a lack of regulation for manure applied as fertilizer and non-point source runoff as a result, because currently the Clean Water Act only covers liquid manure as a point source pollution. The Clean Air Act, when created, CAFOs did not meet emissions quantities thresholds, but currently, due to increased technology and demand, these thresholds are being met through increased emissions of methane, nitrous oxide, and carbon dioxide. And many states exempt farms from state regulations with the right to farm law, and many of this is based on economic backing in these areas. Changes to policy include proposed amendments, including standards for fertilizer application and how much is allowed to be applied, processing limitations, and including point and non-point solution and monitoring runoff, which can be done through the EPA agriculture section and combined with the USDA, which can increase violation fines to cover this process, as well as eliminating the right to farm from state. It should be a federal mandated regulation standard in which the government sets standards, including point and non-point monitoring runoff for all CAFOs across the U.S. Mitigation techniques for CAFOs include methane digesters, which contain methane-consuming microbes, as seen in image 1, that break down microbes into biogas, which then can be used to generate electricity, and these cost on average $1.2 million US per system. Lagoon liners are another viable option, as can be seen in this image on the right, which can reduce groundwater contamination as well as flooding by use of resin liners, and these cost on average $6,500 US per system, as well as wastewater treatments, which vary in cost but use biological filters to remove up to 60% suspended solid waste, and aerated systems, as seen on the right, that can reduce 90% solid waste. What can you do for your part in reducing demand on CAFOs? First, you can start with Meatless Mondays, which saves 100 billion gallons of fresh water, 70 million gallons of gas, 3 million acres of land, and 1.4 billion animals annually. You can support local farms that stimulates the local economy and prevents corporate buyouts, as well as community action, including forums, contacting state representatives, as well as community lawsuits, as seen in the Smithfield example. And here we have the future of CAFOs. The future of CAFOs heavily revolves around changing policies that include new technology and demand, and that marry CAFOs into current Clean Air and Clean Policy Acts as being both point and non-point source polluters and being held to federal regulation standards, including that marriage between the U.S. Department of Agriculture and the EPA, as well as reducing demand on your part by doing Meatless Mondays or buying local, as well as mitigation techniques, including the methane digesters, lagoon liners, and wastewater treatment, as discussed before, as well as educating the community on how they can do their part to have a voice and speak out against CAFOs, such as the lawsuits discussed in the Smithfield plant. Overall, CAFOs have no place in the U.S., and the current state that they're in, including a lack of regulation and policy surrounding them. And therefore, I believe that changing policies as well as reducing demand and implementing mitigation efforts can help to reduce the impacts while also decreasing food insecurity across the U.S. Here are all of my references. Thank you all so much for listening.